Hello makers. In today's video I'm going to show you the internals of a stepper motor and why the fact that people think that they're stripping gears when they jam up is actually quite wrong. So let's get stuck into it. This is actually a NEMA 23 motor. Unlike your standard NEMA 17 that you have on your most 3D printers, this is slightly larger. Now I've gone with the slightly larger one because it's easier to see, but essentially they're the same thing. This one's just bigger and therefore has more torque. So like most stepper motors, it's just a square block. Being a NEMA size, that means this square plate, this round circle, the size of the shaft and the location of the mounting holes are part of a standard. Even the length of the shaft is part of the standard. The depth of the body on this side, however, is not part of the standard and changes for different size steppers. You can get different torque ratings within the frame size. So let's open her up. Most of them are got Allen keys in them, but this one's got Phillips screws in it. And you can see that goes all the way through into the back. There's your screws there. Stepper motors really don't have a lot in them. There's not a lot to them really. Unlike a standard traditional motor, these things are designed to operate locked rotor. So if you stall one, it's not a major drama. You're not going to burn it out. In fact, these things are generally got current controlled power supplies for them. That is, they limit the current being fed to them. Now, this is where it gets a little more tricky. There we go. So that's the front bearing housing. That spring helps keep tension on it. Your front your output bearing, a spacer. And that's the hard part. So I've got the bearing out as well. So as you can see, there are no gears in there, so you're not going to strip them out. You can stall one of these. You will not burn it out. It really doesn't matter. The higher the voltage you can supply to your stepper controller, the faster you can make these go. Now the reason for that is each of these coils is an inductor, and you'll actually find there are one, two, three, four, five, six, seven, 8 coils, and they are arranged into 2 sets of 4. So 1, 2, 3, 4 is one set, and these ones are the other set. If you look at the lines inside here, they are actually stator poles that line up with these. And you'll actually find on this, the bars here and here actually don't line up. In fact, they're exactly halfway off. And that's because we use that as part of our stepping. This completes a magnetic circuit, and it will tend to pull that pole in. So when we energize one pole through here, it will make the lines here align with the lines here to hit right on the mark. It's a little bit strange that they're offset that way, but what you'll find also is that these, when this is back in there, will actually be half offline, and that allows you to step it, the magnetic field. But yeah, I just wanted to open it up and show you what was in one. As you can see, there's not much in it. That's an aluminium housing, so is that. That is magnet steel, laminated and used to create the, I suppose you call it the former, the stator poles, and then the wires are wrapped around each of those. So there's not a lot in these. The only thing that can cause these to fail is if you don't use a stepper driver, or if your stepper driver fails and it puts too much current into these. This one, I think from memory, was rated at 2 or 2.5 amps. So if you exceed that 2 to 2.5 amps, you will cause it to heat up and burn out. If you stay within its current limit range, you can't damage it. The biggest problem you have with stepper motors though is as you speed up the stepper motor, you're creating an AC frequency coming in, and inductors don't like current or change in current direction. So if you run 2.5 amps or 2 amps, then you stop it, the inductors don't like it and they take time to ramp down. Then you switch them and turn them on the other way to reverse the polarity. They don't like that either, and they will resist it. So much so that the faster you go, the more it resists it. And to get your 2 amps still to flow through it, you have to increase your voltage to overcome that back EMF from the inductors. So the higher the voltage you can supply to your stepper driver, the faster you can make these things turn. And that is actually the basis of the maximum speed that we can actually move the head on a 3D printer. It's not based on what a gearbox will do or anything like that. It is based on the voltage that we can use to drive the steppers at the frequency we want for that speed. If we can't drive the stepper with enough power to get that current up to overcome resistances, we're just not going to get the speed, and you'll hear it step or skip steps. A lot of people believe that sounds like grinding. And we do it quite often with extruders. If we're pushing the extruder too hard or the nozzle is blocked, it will skip steps, and that's never a good thing. Not so much for the stepper motor, it really doesn't hurt them, but it doesn't do your print any good at all. So now I've pulled that one apart, I'm just going to put it back together. This will be the hard part. So if you look down through the top here, I'll try and get closer. You can see that the little poles on this end line up with this stator, but they don't line up with this one. I thought there'd be more offset than that. It's only like a 1/3 offset. Okay, so spacer. So when you turn a stepper motor by hand, you can actually feel the cog in those stators aligning. So nothing really to a stepper motor. They are one of the simplest motors. They are essentially a two-phase motor, low speed, that are quite capable of holding a locked rotor, unlike induction motors and even DC motors that don't like holding long periods of time locked rotor. These are designed to operate locked rotor for a very long time, indefinitely in fact. It's a trick question I test other electricians on when I'm determining whether or not they know anything about motors, as to how long a stepper motor can withstand operating locked rotor. The correct answer is indefinitely, whereas nearly every other motor on the market is not very long.
Well, that'll do for this video. If you like these videos, don't forget to click on like, subscribe and ring that notification bell. It's a form of support that costs you nothing and helps the channel a great deal. If you'd like to support the channel further, I have a Patreon account and you can join my Patreons, VIPs, Go Lucky and Lorenz Berger, or my other Patreons, Almorels45 and Ratchet. I also have a Discord server. You can join the growing community there, learn from others in the community and myself, or maybe help others in the community yourself. And we'll see you in the next video.